All right, guys, we're going to get into Unit 4, which is assembly drawings. So we've gone over lines and views, and now we're going to get into kind of like the broader aspect of drawings, of prints. So some of the objectives for this one is to describe the use of detailed drawings, sub-assembly prints, and assembly prints. Compare and contrast detailed drawings, sub-assembly prints, and assembly prints to one another, just what their difference is, kind of reiterating the first point there, and illustrate the features on each of these three types of drawings. Okay, so you've probably heard me mention this on day one when we meet in person. If you've already taken something like the CAD 22, one of the SolidWorks courses, or one of the AutoCAD classes, or you're just savvy and you like messing around with things like Fusion 360 or Onshape or some of these design programs, you're probably going to be a little more familiar with some of this stuff. So good on you guys, but for everyone else, just try and pay attention. I've gone through and highlighted some of the more important things, so take note. All right, and so there's two different print styles. We've got blueprints and modern prints, or what we call shop prints. This is more of a technicality, kind of the same thing, how we're trying to get away from things like MIG and TIG and go to GMAW and SMAW and GTAW. All right, this just kind of makes the terminology a little more universal. So blueprints, this was derived from the blue background with white lines that were initially used way back in the day, early 1900s. Think of if you've ever seen like a, I don't know, World War II documentary and you've seen like drafting rooms where it's just a huge open room. Everybody's got these big tables and they're drafting, they're drawing, designing parts, architecture, things like that. A lot of that was blueprints. All right, and this is done via the diazo process. All right, this is a chemical process, um, kind of similar to you ever seen like an old movie or a movie where they're doing like the old school photography where they got to take the film, they go into a dark room with a red lamp, and they got to put it in the water, and then that gets the image to show up. Okay, it's kind of similar to that. All right, they used special paper and ink, and over time this would fade, and so that's why you would see a lot of designers drafters with tubes of paper, not just for the ease of storing them, but also to kind of help them last longer, to keep them out of the sunlight and stuff like that. They were very guarded with their drawings back in the day because they would fade over time and it become difficult to read. We don't have that problem anymore because everything we do now is pretty much done on CAD software programs. Again, things like AutoCAD, SolidWorks, Fusion 360, programs like that. And then you're just printing them on normal printer paper. We have digital copies of everything. So that's kind of the difference between a blueprint and a shop print. This can be produced, shop prints, with multiple colors. Typically, though, it's just white paper with black lines and text. Um, some still call these blueprints. Yes, Lincoln, some people still call them blueprints. It's just one of those things people don't know. It's not, I don't know, it's not going to hurt anybody. So it's fine. But in all technicality, if you want to get real, snooty, if you're out in industry and somebody hands you quote unquote blueprints, oh, it's a shop print, not a blueprint. All right, don't do that. All right, don't be snooty. If you're going to correct somebody, if you're that kind of person, just, now you know what the difference is. Now you can explain it to them. All right, but that's the difference between blueprints and what we now call shop prints. Okay, so in a detailed print, this is an orthographic drawing. All right, typically with three views, your multi-view drawing is an orthographic drawing. Your multi-view is an orthographic drawing. An orthographic drawing is just a you're giving three-dimensional depth via 2D drawings. All right, so in those multi-view drawings, that's why we typically have the front view, top view, and side view. That usually gives you the most detail of the part you're looking at. You can also have a bottom view, top view, right side view, left side view, back side. It just depends on what the part requires, whatever gives you the most detail. Okay, a detailed print should provide the size dimensions needed along with dimensions. Okay, so size dimensions and dimensions. What's the difference? Well, size dimensions. How big of a hole do I need? All right, that's a size dimension. Where does that hole go? That's your dimension. All right, to locate any holes or other machined features in the part. Usually, all right, not always, but usually only one part on one drawing. Okay, so if you see words like usually or sometimes, be careful, take note of that. There might be some tricky questions on the final exam and some of the units. Make sure you're paying attention to whether or not it is an always or never, or a usually and an always, okay? So usually only one part on the drawing or page. Two or more parts with less detail can be placed on one detailed print if multiple parts on the print are components of the same sub-assembly. All right, so a sub-assembly and assembly are very similar. It's just a sub-assembly is going to be a group of components that go together to form a part, and then a sub-assembly is going to be those components put together into a sub-assembly, and those will go onto another part, into the full assembly, right? You get projects that have thousands and thousands of parts, and so we have assemblies, which is the entire product, the entire part, and then sub-assemblies, right? You might have small control panels, control boxes that go on a large skid steer generator, something like that. You've got multiple sub-assemblies in that entire assembly, and all the components are the individual pieces that go together to either make an assembly or a sub-assembly. These seldom, all right, so not never, seldom include welding symbols. And then tolerances will be specified along with notes to aid in the production of the part. So here's an example of a detailed print. And look, so seldom, but here we are, a little weld symbol right there. Okay, so this is a detailed print. We'll ignore this stuff for now. Don't worry about that. There's a unit that kind of breaks down all of that stuff. We're just kind of focused on this right here. All right, this is our orthographic drawing. We're in a multi-view. So we've got the front, the top, and the side. And that gives us all the information we should know. Right here, okay, a note, your leader line, 5 holes punched, 15/16 square and countersunk for number 3 head plow bolt. And obviously we don't need to dictate every single hole, they're all the same, okay? And then we have the measurements, the locations of the holes, boom, boom, and then we have our weld symbol right here. So this is calling for a 3/16 surface weld, hard surface, all right, in this section right here. All right, and then we can also see we've got the material thickness, 9/16 in the side view right here. Hard face before beveling edges, your note. Okay, so this is a detailed print. This is telling you a lot of information about the part, about how to fabricate that part. In a sub-assembly print, this can involve just 2 sub-assemblies or made up of many. Okay, so this can be multiple sub-assemblies into one sub-assembly. It gets a little confusing, but we'll go over some examples. So each sub-assembly part will have a print providing required instructions detailing the fabrication process. This will include orthographic drawings, right, your multi-view. This will contain welding symbols if you're going to be welding. This will have the part list or bill of materials. Okay, part list, not your cut list. That's a different thing. A cut list is the material, size, and shape profile that's required. The part list identifies part numbers, numbers or letters. Sometimes you use numbers, sometimes you use letters. The required number of any one part, so quantities, description of that part, detailed print number to reference that part, right? So if there's a part that has a print of its own, it's going to detail that print number so you can reference it for each part, and dimensions for each part. Okay, often the sub-assembly prints are the ones the welders will see. So take note of that. Sub-assemblies are usually the ones the welders will see. So here's an example of a sub-assembly print. So this is a couple pieces, okay, components put together in a sub-assembly that will go on to another assembly. All right, this is a connecting tube assembly, manifold to muffler. All right, so this is a piece of exhaust, and you can see right here you got this this note with the leader lines. This is just telling you, because this is not a multi-view. All right, this is just a sub-assembly, and this is just telling you, hey, this part 1, boom, is this part 1 right here, and then you got part 2 right here, and then again we've got a weld symbol right on the inside. So you're going to do an inside weld right where that arrow meets this hidden line to this bracket all around. Okay, fillet weld, 16th inch fillet weld right there. So this would be the thing that you hand to the fabricator or welder, and they should be able to put those two parts together, weld it up, boom, send it off to the assembly. All right, assembly prints. So sub-assembly parts brought together and using assembly print project completely assembled and ready to use. Okay, so again, sub-assemblies, you can have multiple sub-assemblies, get all the sub-assemblies get put together in the assembly part, in the assembly print. All right, and the assembly print should be what that finished product is, all the components together. This is commonly used at construction site or in the field, right, where this product is going. Again, orthographic drawings contains welding symbols if the welding is going to be used to join those pieces together. May include notes to provide instructions for final phase of process if necessary. And then again, the parts list or bill of materials is often, not always, but often included. So here's an assembly print. All right, if we're looking down here at the parts list, we've got base subassembly, holder subassembly, and then some wing nuts. All right, so we're putting two subassemblies together. So we're looking at item one, boom, item one right there, item one right here, this cross that you're seeing, that's item one. All right, we need one of those, base subassembly. So that's what that part is called. So there should be another print with the base subassembly for the material and the parts needed to put that together. And then same for item number two. So item number two, you can probably see it the best right here. These kind of T-handled pieces, boom, boom, boom. Item number two. All right, and we need four of those. That's the quantity right there. This is the holder subassembly. All right, so again, subassembly, so it's going to have its own print with the required material parts, how to weld it together if these were getting welded together. And then here in the assembly print, all those subassemblies are coming together to make a spool adapter. Okay, so just for reference, you guys just think of a wire feeder. Sometimes people need a different sized spool of wire, or maybe they want a larger spool of wire. Maybe they're tired of swapping out those 33-pound spools you guys are used to for like MIG wire. They want to go up to like a 50-pound spool of wire, so they need an adapter to hold that wire. So that's what this is. This would go on your spool, and then you could put a larger diameter spool so you have more wire to burn through before swapping it. That's what this is, spool adapter. Okay, and then part number three, or item number three, is just wing nuts. Wing nuts, boom, 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 right there, boom, boom, boom. Okay, so this is how those components come together to form the final product. All right, so that's the difference between sub-assemblies and assemblies. The assembly print should always be the final product. So obviously we have variations in prints, a lot of, seldoms or sometimes. It just depends. The main thing when you're drafting or designing a product, you want to reduce the number of prints required for a large project. Okay, a large project is almost like playing a game of telephone. And a good drafter, a good designer will try and get as much of that information in as little prints as required. That way you're just not getting saturated with information. You're not over emphasizing too much information. All right, so we want to eliminate how much information or how many prints there are to condense that information. Okay, so but some variations, right? We may combine detail information and subassembly information onto one print. If there is, if there's small parts, if there's not a whole lot of detail, then we can combine some of that information that's typically not on a print, just to save paper, save prints. All right. So here's an example. Detail and assembly on one print. So you look at this, you should be able to hand this to a fabricator and they would be able to make the part. It's got all the information. We can see right here, 5/8 diameter, outside diameter, so I'm assuming this is 5/8 tubing. 5/8 tubing right here, okay? We have the length of the part. We've got the information so that we can make the chamfer, 2 inches with a 1/4 inch flat spot. We've got the location of a hole right there, 5/32, and its location right there off the base. We have where this piece mates to this piece, 2.5 inches off the edge. And then we have the weld symbol, okay? So weld all around, 1/4 inch fillet weld. So you should be able to hand this to a fabricator and boom, that part is done. all in one little get-go. So this is kind of a simple example. Here's a little more detailed example, but same principle. Detail and subassembly on one print. All right, but this is a good example of how we can go from a simple part to, okay, now we're getting a little more information. We've got more holes, we've got more tolerances, we've got more welding, we've got more chamfers. So at a certain point, it's not really worth having this much information on a print. Okay, it's kind of up to the drafters, the designers, to kind of figure out. All right, at this point, we need to separate these because there's just too much information on this one print. All right. So organization of prints. So a complete set of prints should be numbered and organized by sub-assemblies. So how many sub-assemblies are in that assembly? The assembly print is always the first print in a set. Next is going to be the sub-assemblies. And after every sub-assembly, there's going to be the detailed prints associated with that sub-assembly's print. All right. So if there are one sub-assembly, the next page is going to be detailed prints associated with that subassembly. And then you go to the next subassembly, and then following that will be, again, detailed prints associated with the second subassembly, and then third, the fourth, the fifth, however many there are. The pattern continues with all the parts and subassemblies for the project.